At 3:47 in the afternoon, on February 23, 1945, Oberleutnant Klaus Bärenfänger watched through his Panther tank's periscope as an American Sherman maneuvered across a muddy Belgian field near the German border. He had seen dozens of Shermans destroyed in the past 6 months. The Panther's 75mm gun could penetrate Sherman's armor from over a mile away. The Sherman's 75mm gun struggled to penetrate a Panther's frontal armor even at close range. This engagement should have been simple. Bärenfänger's Panther was hull down behind a low ridge. The American tank was exposed, moving across open ground. One shot, that's all it would take. But something was different about this Sherman. It moved differently. It turned faster. When Bärenfänger's gunner fired and missed, the American tank didn't retreat or seek cover like the standard Shermans always did. Instead, it accelerated directly toward the Panther's position, weaving left and right, closing the distance before the German crew could reload. The Sherman fired on the move. The shot missed, but the American tank kept coming, its suspension absorbing the terrain without slowing down. Bärenfänger ordered his driver to reposition. The Panther's engine roared. The 60-ton machine lurched forward. But in the time it took the Panther to travel 50 meters, the American tank had covered twice that distance and flanked them. The second shot from the Sherman struck the Panther's side armor. Penetration. The German crew bailed out as smoke filled the fighting compartment. Bärenfänger survived. His tank did not, and as he watched that Sherman continue moving across the battlefield, hunting other German positions with a speed and agility no Sherman should possess, he realized something had changed in the balance of armored warfare. The tank he had just faced was not a standard M4 Sherman. It was an M4A3E8, nicknamed the Easy 8 by American crews, and its horizontal volute spring suspension system, HVSS for short, had just demonstrated a tactical advantage that German armor doctrine had never anticipated. Mobility wasn't just about top speed or horsepower. It was about how quickly a tank could accelerate, how sharply it could turn, how effectively it could fire while moving, and how well its crew could fight after hours of cross-country movement. The Easy 8 excelled at all of these. The Panther excelled at none of them. This is the story of how one suspension system changed the nature of tank combat in the final months of World War II in Europe, and how German tank commanders who had spent years dismissing American armor as inferior finally confronted a Sherman they could not simply outgun. The problem with German armor in late 1944 was not firepower or protection. It was mobility, and more specifically, the kind of mobility that actually mattered in combat. German tanks were designed with a specific tactical philosophy: heavier armor, bigger guns, longer engagement ranges. The Panther tank embodied this perfectly. Sloped frontal armor up to 100 millimeters thick, a 75mm high-velocity gun that could destroy any Allied tank at ranges exceeding 2,000 meters. A Maybach engine producing 690 horsepower. On paper, it was superior to every Allied tank in service. In practice, it had serious problems that were becoming impossible to ignore. The Panther weighed 45 metric tons, nearly 10 tons heavier than a standard Sherman. That weight stressed every mechanical component. The final drive, the transmission system that connected the engine to the tracks, failed constantly. German maintenance reports from late 1944 show that Panthers had a mechanical failure rate of approximately 35%. More than 1 in 3 Panthers broke down before being knocked out by enemy fire. The suspension system was equally problematic. Panthers used torsion bar suspension with interleaved road wheels. The design looked impressive. 16 small road wheels per side, overlapping in a complex pattern that distributed weight efficiently and provided a smooth ride. But in combat conditions, especially in winter, the system became a nightmare. Mud packed between the interleaved wheels. When temperatures dropped below freezing, that mud turned to ice. The wheels froze solid. Tank crews had to spend hours every morning chipping ice from the suspension just to get their tanks moving. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Panther's transmission required the driver to double clutch every gear change. Under combat stress, with the tank taking fire, drivers made mistakes, grinding gears, stripped teeth, broken synchronizers. A Panther with a damaged transmission was a 45-ton pillbox. It could shoot, but it couldn't move. And in fluid battlefield conditions, where positions changed rapidly, immobility meant death. American tankers noticed this. They noticed that Panthers were fast in a straight line on roads, but slow to accelerate from a stop. They noticed that Panthers took wide, slow turns. They noticed that when a Panther had to reverse quickly, it often stalled or threw a track. These weren't minor inconveniences. These were tactical vulnerabilities that could be exploited. The standard M4 Sherman had its own problems. Its vertical volute spring suspension, VVSS, was reliable but crude. Each road wheel was connected to a vertical spring housed in a cylindrical casing mounted to the hull. The system was simple, easy to maintain, and nearly indestructible, but it provided a rough ride. The Sherman bounced and pitched over uneven terrain. Crew fatigue was significant after long movements, and the narrow tracks, just 16.5 inches wide, meant the Shermans. Ground pressure was high. In soft ground or mud, Shermans sank. In snow, they bogged down. More critically, the VVSS Sherman couldn't fire accurately while moving. The gun would bounce too much. The gunner couldn't keep the sight on target. American tank doctrine compensated by teaching crews to stop, fire, then move. But stopping meant presenting a stationary target. Against German 88mm guns or Panther 75mm guns, a stationary Sherman was a dead Sherman. By mid-1944, American ordnance officers recognized they had a problem. The Sherman was mechanically reliable, easy to produce, and available in massive numbers, but it was outgunned and out-armored by German heavy tanks. Proposed solutions focused on bigger guns or thicker armor, but both required a complete redesign. The T-26 program, which would eventually produce the M26 Pershing heavy tank, was years away from mass production. Then someone remembered a suspension system that had been tested and rejected 2 years earlier. In 1942, engineers at the Detroit Arsenal had developed an improved suspension for the Sherman. Instead of vertical springs, they used horizontal volute springs. Each pair of road wheels was mounted on a bogie with 2 horizontal coil springs. The springs were wider, softer, and provided significantly more travel than the vertical design. The system had other advantages. The track was wider, 23 inches, instead of 16.5. That reduced ground pressure by nearly 30%. The tank could cross soft ground that would bog down a VVSS Sherman. The ride was smoother, crew fatigue decreased, and most importantly, the gun remained more stable over rough terrain. But in 1942, the US Army rejected HVSS. The reasoning was simple. HVSS was more complex to manufacture. It required different tooling. Production of standard Shermans would have to slow down while factories retooled. And in 1942, quantity mattered more than quality. The Allies needed thousands of tanks immediately. They needed them in North Africa, then Sicily, then Italy. Minor improvements in ride quality didn't justify production delays. By late 1944, the situation had changed. The Allies had enough tanks. What they needed were tanks that could fight German Panthers and Tigers without relying solely on numerical superiority. The HVSS design was pulled out of storage, updated, and rushed into production. The result was designated the M4A3E8. The M4A3 designation indicated it used a Ford GAA V8 engine, the most powerful and reliable of all Sherman engines, producing 500 horsepower. The E8 designation indicated it was the 8th major modification to the Sherman design. This modification was the HVSS suspension, combined with wider tracks and several other improvements. Production began in December of 1944. The first EZ-8s reached combat units in Europe in January of 1945. By February, enough had arrived that several armored divisions began replacing their older Shermans with the new model. Tank crews noticed the difference immediately. Sergeant Lafayette Poole, a tank commander with the 3rd Armored Division, wrote in a letter home that the EZ-8 felt like a completely different vehicle. He described how the tank could cross terrain that would have stopped his previous Sherman. He wrote about firing the main gun while moving at 20 miles per hour and actually hitting targets. He mentioned that his crew arrived at objectives less exhausted because the ride was smoother. Poole didn't live to see the war's end. He was killed in action in September of 1944 before the EZ-8 entered service, but his observations about mobility and crew effectiveness were echoed by hundreds of other American tank commanders who transitioned to the new model. The EZ-8's advantages were not immediately obvious to German tankers. When Panthers first encountered the new Shermans in early February of 1945, they looked nearly identical to standard M4s. Same basic hull shape, same turret, same 76mm gun that had been mounted on late-model Shermans since mid-1944. The only visible difference was slightly wider tracks and different suspension bogies. German intelligence officers noted the new suspension in reports but didn't consider it significant. After all, how much difference could suspension make? The Panther still had superior armor and a better gun. Engagement doctrine remained unchanged. Spot the Sherman at long range, fire from hull-down position, destroy it before it could close to effective range. The Panther's advantages in firepower and protection meant that tactics favored long-range engagements where German tanks could exploit their superior guns while remaining invulnerable to American fire. This doctrine had worked throughout 1944. During the Battle of the Bulge in December, German Panthers and Tigers had destroyed American armor in large numbers during the initial offensive. When American Shermans tried to engage at medium range, they died. When they tried to close distance and flank, they were too slow. German tank commanders had every reason to believe their tactical and technical superiority would continue. Then they encountered EZ-8s that could move faster, turn sharper, and fight more effectively at close range than any Sherman they had faced before. The tactical impact became clear during fighting near the Roa River in late February of 1945. The U.S. Ninth Army was pushing toward the Rhine. German forces were conducting a fighting withdrawal using armor to slow the American advance. Panther tanks from the Panzer Lehr Division were positioned to defend a series of villages along the American axis of advance. The German plan was standard. Let American infantry and supporting Shermans advance into the kill zone. Engage from prepared positions at 1,000 to 1,500 meters. Destroy enough tanks to stop the attack. Withdraw before American artillery could respond. The Panthers were positioned hull down behind rubble and earthworks. They had clear fields of fire. The American tanks would be silhouetted against open ground. On February 25th, a company of EZ-8s from the 2nd Armored Division approached the village. German gunners waited for the Americans to enter effective range. At 1,200 meters, the first Panther fired. The shot struck an EZ-8 in the frontal hull. The American tank stopped, smoke pouring from the engine deck. The crew bailed out. It appeared to be a standard engagement. Then, the remaining EZ-8s did something unexpected. Instead of stopping to return fire or retreating to cover, they accelerated directly toward the German positions. They didn't advance in a straight line. They maneuvered, using small terrain folds and rubble for partial concealment, moving at speeds that shouldn't have been possible for tanks crossing rough ground. German gunners fired again. Most shots missed. The EZ-8s were moving too fast and changing direction too quickly. The few hits that landed struck at angles where even the EZ-8's relatively thin armor could deflect shells. By the time the Panthers could reload and reacquire targets, the Americans had closed to 400 meters. At that range, the EZ-8's 76mm gun could penetrate a Panther's side armor, and because the EZ-8s were now spread across a wide front, the German tanks couldn't engage all of them simultaneously. American tankers flanked the Panthers, fired into their sides and rears, and destroyed 3 before the German commander ordered a withdrawal. The withdrawal went badly. Panthers were excellent in forward gear, but sluggish in reverse. The transmission limited reverse speed to about 4 miles per hour. Meanwhile, the Easy-8s could maintain 15 to 20 miles per hour while maneuvering across broken ground. 2 Panthers threw tracks while attempting to reverse quickly over rubble. They were abandoned. A third was hit while attempting a 3-point turn to retreat. The German company lost 6 Panthers in less than 10 minutes, not to overwhelming firepower, not to airstrikes or artillery, but to American tanks that could maneuver faster than German doctrine anticipated. Oberleutnant Bärenfänger, the Panther commander from the opening of this story, survived that engagement. He was reassigned to another Panther and fought in several more actions before the war ended. After Germany's surrender, he was interviewed by American intelligence officers who were compiling information on German perceptions of Allied equipment. The interview transcript, dated June 7, 1945, included Bärenfänger's assessment of American armor. He acknowledged that the Sherman had always been mechanically reliable and available in great numbers, but he stated clearly that prior to early 1945, German tanks maintained a decisive qualitative advantage. Then, he said, a new model of Sherman appeared with improved suspension that allowed it to exploit terrain and maneuver in ways that previous Shermans could not. Bärenfänger's exact words, translated from German, were, "This tank moved like a light vehicle, but carried the armor and gun of a medium tank. We could no longer rely on engaging at long range because it would close distance too quickly. We could no longer rely on our superior armor because it would maneuver to our flanks before we could reposition." The tactical advantage we had maintained for 2 years disappeared in a matter of weeks. He was not exaggerating. By March of 1945, German armor commanders throughout the Western Front were reporting similar experiences. Easy-8s were operating with a mobility advantage that negated many of the Panther's strengths. German tanks still had better guns and heavier armor, but those advantages mattered less when American tanks could dictate engagement ranges and maneuver faster than German tanks could respond. The suspension system itself was elegantly simple. Each side of the Easy-8 had 3 bogies. Each bogie supported 2 road wheels. The wheels were mounted on arms that pivoted on horizontal pins. 2 horizontal coil springs per bogie absorbed impacts and allowed the wheels to move vertically up to 9 inches. This was significantly more travel than the WWII system's 5 inches. More suspension travel meant the tank could cross larger obstacles without the entire hull pitching upward. The gun remained more stable. The tracks stayed in contact with the ground more consistently. The wider tracks, 23 inches compared to 16.5, distributed weight over a larger area. Ground pressure dropped from 13.5 pounds per square inch to 10.7 pounds per square inch. Those numbers sound technical and abstract, but the practical effect was dramatic. An Easy-8 could cross muddy ground that would trap a WWII Sherman. It could climb steeper slopes. It could turn sharper without throwing a track. And most critically, it could maintain higher speeds over rough terrain without exhausting the crew or shaking the gun off target. American tank crews described the difference between WWII and HVSS as like riding in a truck versus riding in a car. The WWII Sherman bounced and jolted over every bump. After 6 hours of cross-country movement, crews were physically exhausted. Vision was blurred from constant shaking. The gunner's ability to acquire and engage targets was degraded. The Easy-8 provided a smooth enough ride that crews remained combat effective even after long movements. Gunners could keep their eyes on their sights without headaches. Loaders could move ammunition without being thrown. Against steel surfaces, drivers could maintain situational awareness because they weren't fighting the controls constantly. This might seem like a minor comfort issue, but in combat, crew effectiveness directly determined survival. A tired crew reacted slower. They made more mistakes. They failed to spot threats. An alert, comfortable crew spotted enemies first, fired first, and killed first. The Easy-8's suspension improved crew performance in ways that had nothing to do with armor thickness or gun power, but everything to do with whether the crew won the engagement. German tankers had the opposite problem. Panther crews were exhausted after long movements. The torsion bar suspension provided a relatively smooth ride compared to earlier German tanks, but the Panther's weight and the crew's workload took a toll. The gunner in a Panther had to manually traverse the turret using a hand wheel if the hydraulic system failed, which it often did. Traversing a Panther turret manually required 60 turns of the hand wheel to rotate 360 degrees. In combat, when an American tank suddenly appeared on the flank, a Panther gunner might need 20 or 30 turns of the wheel to bring the gun to bear. That took time. 15 seconds, 20 seconds, long enough for the American tank to fire first. The EZ-8's turret had powered traverse that worked reliably. The gunner could swing the turret to face a new threat in 3 to 5 seconds. Combined with superior mobility, this meant EZ-8s could get into position faster, acquire targets faster, and engage faster than Panthers could respond. Speed of action, not just speed of movement, became the decisive factor. By late March of 1945, the US First and Third Armies were crossing the Rhine and driving deep into Germany. Armored divisions led the advance. EZ-8s were now present in significant numbers, supplementing and in some cases replacing older Shermans. German resistance was collapsing, but isolated Panther units continued fighting. One engagement on March 29th near Paderborn illustrated the EZ-8's advantages in fluid, mobile warfare. A battalion of EZ-8s from the 3rd Armored Division encountered a company of Panthers defending a crossroads. The German tanks were positioned in a classic ambush, hull-down positions, overlapping fields of fire. The Americans would have to advance across open ground to reach the crossroads. In earlier battles, this setup would have resulted in heavy American casualties. The Panthers would destroy several Shermans, force the Americans to call in artillery or air support and withdraw before the position became untenable. But the American commander didn't advance directly into the kill zone. Instead, he sent one platoon of EZ-8s to demonstrate in front of the German position, drawing fire and fixing the Panthers in place. Meanwhile, 2 other platoons maneuvered wide to the flanks, using rolling terrain to mask their movement. The EZ-8s crossed ground that standard Shermans would have struggled with, muddy fields and small stream beds. They moved fast, covering 2 miles in less than 15 minutes. When they emerged on the Panthers' flanks, the German tanks were still focused forward, engaging the platoon that was demonstrating. The flanking EZ-8s opened fire at 300 to 400 meters, hitting side and rear armor. 4 Panthers were destroyed in the first volley. The remaining German tanks attempted to reposition, but they were too slow. More hits, more destroyed Panthers. The entire engagement lasted 8 minutes. The German company was eliminated without the Americans calling for artillery or air support. This type of rapid, mobile flanking maneuver had always been theoretically possible, but standard Shermans lacked the cross-country speed to execute it before German tanks could react. The EZ-8 made it practical. American armor commanders began using flanking tactics routinely because they knew their tanks could move fast enough to make the maneuvers work. German after-action reports from April of 1945 show increasing frustration with American tank mobility. One report from Panzer Brigade 106 stated that American tanks were now attacking from unexpected directions and exploiting gaps in German lines before reinforcements could arrive. The report specifically mentioned that newer model Shermans with wider tracks and improved suspension were capable of rapid cross-country movement that German intelligence had not anticipated. Another report from Panzer Division Müncheberg described an engagement where American tanks bypassed prepared defensive positions entirely by moving through terrain that German planners had considered impassable for armor. The report concluded that standard defensive tactics based on channeling enemy armor into kill zones were no longer effective because American tanks could maneuver around those zones. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The EZ-8 wasn't invincible. German guns could still penetrate its armor. A well-placed shot from a Panther's 75mm gun or an 88mm anti-tank gun would destroy an EZ-8 just as easily as it would destroy a standard Sherman. But the EZ-8 made it much harder for German gunners to get that well-placed shot. Tanks don't fight in isolation. They operate as part of combined arms teams with infantry, artillery, and air support. The EZ-8's mobility made it a more effective member of those teams. It could keep pace with advancing infantry better than heavier tanks. It could respond to calls for fire support faster. It could exploit breakthroughs more effectively. During the final weeks of the war, as Allied forces pursued retreating German units across central Germany, mobility mattered more than firepower or armor. The side that could move faster, maneuver more effectively, and maintain operational tempo won engagements. The EZ-8 excelled at this type of warfare. Standard Shermans could do it, but they wore out crews and broke down more frequently. Panthers could do it in theory, but their mechanical unreliability meant many never reached the battlefield. Tigers were too heavy and too slow. German tank destroyers, like the Panther, had excellent guns, but poor mobility. The EZ-8 hit a sweet spot of reliability, mobility, and combat power that made it ideal for the fluid, fast-moving battles of April and early May 1945. American tankers who fought in EZ-8s consistently praised the vehicle. After the war, the U.S. Army conducted surveys asking tank crews which vehicles they preferred. The EZ-8 received overwhelmingly positive ratings. Crews appreciated its mechanical reliability, its comfortable ride, its responsive handling, and its ability to keep fighting even after taking damage that would have disabled other tanks. One survey comment from a tank commander in the 7th Armored Division summarized the EZ-8's appeal. "You could drive it hard all day, every day, and it wouldn't quit. You could maneuver it through terrain other tanks couldn't handle. You could hit what you aimed at, even while moving. And when you got hit, you had a decent chance of surviving and getting the tank back into action. That's all a tank crew really wants." The German perspective on the EZ-8 evolved throughout the spring of 1945. Early encounters were dismissed as isolated incidents. German commanders assumed that individual crews had made tactical errors or that American numerical superiority had overwhelmed isolated positions. But as reports accumulated, patterns emerged that could not be ignored. At OB West, the German High Command for the Western Front intelligence officers compiled reports from surviving Panther crews. The reports were remarkably consistent. American tanks with wider tracks and improved suspension were demonstrating mobility characteristics superior to previous Sherman models. They could traverse difficult terrain more quickly. They could maneuver aggressively in close combat. They could maintain higher operational tempos without mechanical failure. One intelligence summary from early April stated that the new Sherman variant appeared to combine the mechanical reliability American tanks were known for with cross-country performance comparable to German medium tanks. The summary noted that this combination was particularly dangerous because it eliminated the tactical vulnerabilities that German crews had learned to exploit against earlier Shermans. German tank crews had been trained to use the Panther's superior gun range and armor protection to engage Shermans at distances where American tanks could not effectively return fire. This required maintaining long sight lines and preventing American tanks from closing to ranges where their guns became effective. The EZ-8's superior mobility made this tactic much more difficult to execute. If a Panther crew fired and missed at long range, the EZ-8 could close the distance before the Panther could reload and fire again. If a Panther crew was forced to reposition, the EZ-8 could maneuver faster and maintain contact. If a Panther attempted to withdraw, the EZ-8 could pursue more effectively. The tactical initiative shifted to whichever side could move and react faster, and the EZ-8 had clear advantages in that type of engagement. Hauptmann Ernst Bachmann, a Panther commander with SS Panzer Division Das Reich, survived the war and was interviewed extensively about his combat experiences. Bachmann was one of Germany's most successful tank aces, credited with destroying over 80 Allied armored vehicles during the war. His tactical expertise was widely respected, and his observations about Allied equipment were considered authoritative. In interviews conducted in the 1950s and 60s, Bachmann acknowledged that the EZ-8 Sherman represented a significant improvement over earlier models. He stated that while the Panther maintained advantages in frontal armor and gun penetration, those advantages were less decisive against EZ-8s because of their superior tactical mobility. Bachmann specifically mentioned that EZ-8 crews seemed more aggressive and more willing to maneuver for flank shots rather than engaging frontally. Whether this aggressiveness came from improved crew confidence in their vehicle's mobility or from better training was unclear, but the result was that EZ-8 crews fought differently than crews in standard Shermans. They took more risks, they maneuvered more boldly, they closed to effective range more quickly. This behavioral change made them more dangerous opponents. The technical reasons for the EZ-8's mobility advantages were well understood by German engineers who examined captured examples. In late April, American forces overran a German tank repair facility near Kassel. Among the vehicles in the facility was an EZ-8 that had been captured, damaged, and brought there for evaluation. German engineers had partially disassembled it to examine the suspension system. Their reports, recovered by American intelligence officers after the war, provided detailed technical analysis of the HVSS design. The reports acknowledged that the horizontal spring arrangement provided superior suspension travel and better weight distribution than the vertical spring system used on earlier Shermans. The reports noted that the wider tracks reduced ground pressure significantly, improving performance in soft terrain. The German engineers also noted that the HVSS system was simpler to maintain than the Panther's torsion bar suspension with interleaved wheels. Changing a damaged road wheel on an EZ-8 required removing 2 wheels and could be accomplished by a trained crew in under an hour. Changing a damaged inner road wheel on a Panther required removing up to 8 outer wheels and typically took 4 to 6 hours, assuming the crew had the proper tools and replacement parts. This maintenance advantage meant EZ-8s spent less time out of action for repairs and could be returned to combat faster after taking damage. In sustained operations, this translated to higher operational availability. An armored division equipped with EZ-8s could maintain more tanks in combat-ready condition than a division equipped with Panthers, even if both divisions started with equal numbers of vehicles. The German engineering reports concluded that the EZ-8 represented a mature, well-optimized design that prioritized reliability and operational effectiveness over maximum performance in any single category. The reports contrasted this with German tank design philosophy, which emphasized maximum firepower and protection even at the cost of mechanical complexity and reduced reliability. This was not a new criticism. German tank designers had been aware since 1943 that their vehicles were becoming too complex and too difficult to maintain under field conditions, but German military doctrine, driven by Hitler's personal interest in tank development, continued to demand heavier armor, bigger guns, and more advanced technology. The result was a series of tanks that were formidable in single engagements, but could not be produced in sufficient numbers or maintained effectively in prolonged operations. The Panther was the most successful of these designs. It was a genuinely excellent tank when it worked properly, but it worked properly less often than German commanders needed. Mechanical reliability rates for Panthers in April of 1945 were below 50% in many units. More than half the Panthers in a given unit were out of action at any given time due to mechanical problems, not enemy action. The EZ-8, by contrast, maintained operational readiness rates above 85%. American armored divisions could count on having the vast majority of their tanks available for combat on any given day. This numerical advantage, combined with the EZ-8's improved mobility, created a situation where German tank units were consistently outnumbered by available American armor, even when paper strength appeared more even. The final major engagement, involving significant numbers of Panthers, occurred in the Ruhr Pocket in mid-April 1945. Over 300,000 German troops were surrounded by American forces. Among them were remnants of several Panzer divisions, including approximately 40 operational Panthers. the Germans attempted breakout attacks to escape the encirclement. These attacks were met by American armored units that included substantial numbers of EZ-8s. The fighting was intense but brief. German tanks attempting to break through American lines were engaged at close range in towns and villages where long-range gunnery advantages meant nothing. The EZ-8's superior mobility in urban terrain proved decisive. They could maneuver through rubble-filled streets more effectively than Panthers. They could reverse and reposition faster. They could respond to threats from multiple directions more quickly. Within 3 days, most of the German armor in the pocket had been destroyed or abandoned. The Ruhr pocket surrendered on April 18th. Among the captured equipment were 17 Panthers that had been abandoned due to mechanical failure, not enemy fire. Their crews had simply run out of fuel or spare parts and left them behind. By late April 1945, the war in Europe was effectively over. German forces were collapsing across all fronts. The EZ-8's combat debut had lasted less than 4 months, too short a time to fundamentally alter the war's outcome, which had been decided by 1944. But in those 4 months, the EZ-8 had demonstrated what proper attention to mobility and crew effectiveness could accomplish. It had shown that suspension design mattered as much as armor thickness or gun size. It had proven that tactical mobility could compensate for deficiencies in other areas. It had validated the concept that a well-balanced, reliable tank was more valuable than a theoretically superior tank that broke down constantly. These lessons would influence tank design for decades after the war ended. The United States Army continued producing EZ-8s after Germany's surrender. The tank saw extensive combat in the Korean War from 1950 to 53. In Korea, the EZ-8's mobility advantages were even more valuable than in Europe. Korean terrain was mountainous and difficult, with poor roads and limited tank country. Standard Shermans struggled in these conditions. EZ-8s performed significantly better. American tank crews in Korea specifically requested EZ-8s over other available models. When the Army attempted to replace some EZ-8 units with M26 Pershing heavy tanks, the crews objected. The Pershing had a better gun and heavier armor, but it was slower, less reliable, and harder to maintain in field conditions. Tank commanders wanted vehicles they could count on, and the EZ-8 had proven itself thoroughly reliable. The EZ-8 remained in American service through the 1950s. It was gradually replaced by the M46, M47, and M4A3E8 Patton series medium tanks, all of which incorporated design lessons learned from the EZ-8's success. Most notably, all subsequent American medium tanks used wide tracks and advanced suspension systems that prioritized mobility and crew comfort alongside firepower and protection. International sales of surplus EZ-8s continued into the 1960s and 70s. Israel used EZ-8s in the 1956 Sinai campaign and the 1967 Six-Day War. The tanks were upgraded with more powerful engines and improved guns, but the basic HVSS suspension remained unchanged. Israeli tank crews praised the EZ-8's reliability and mobility in desert conditions where other tanks failed. Several South American countries operated EZ-8s into the 1980s. Paraguay used them in the Chaco region, where mobility in difficult terrain was essential. Chile operated them in mountainous regions. Argentina maintained a substantial fleet through the 1970s. In every case, the EZ-8's combination of reliability and mobility made it valuable long after more powerful tanks had become available. The last combat use of EZ-8s occurred in the 1990s during the Yugoslav wars, where several nations deployed them in limited numbers. By this point, the tanks were hopelessly obsolete by modern standards, but they still functioned. They still moved. And in some situations, a working 50-year-old tank was better than no tank at all. The EZ-8's legacy extended beyond the vehicle itself. It demonstrated that incremental improvements to existing designs could be as valuable as radical new developments. The HVSS suspension was not revolutionary technology. It was an evolution of existing concepts applied thoughtfully to solve specific problems. But that evolutionary approach produced results that mattered in combat. This contrasted sharply with German tank development during the war, which increasingly pursued revolutionary designs that promised dramatic capabilities but delivered constant mechanical problems. The Panther was the most successful German heavy tank, but even it suffered from over-engineering and insufficient testing. Later, German tanks like the Tiger II and the Maus were mechanical nightmares that could barely move under their own power. The EZ-8 showed that pragmatic engineering, focused on reliability and crew effectiveness, could defeat theoretically superior designs that prioritized maximum performance over operational sustainability. This lesson influenced post-war American military procurement across all domains. Reliability became as important as capability. Maintainability became as important as firepower. Crew effectiveness became as important as technical specifications. When the U.S. Army developed the M4A3E8 Patton tank in the 1950s, the design team explicitly referenced EZ-8 feedback from Korean War veterans. The M4A3E8 used a torsion bar suspension, similar to the Panthers, but simplified for easier maintenance. It used a powerful but reliable engine. It prioritized crew comfort and ergonomics. The result was a tank that American crews trusted and that remained in service with various armies into the 21st century. German tank commanders who survived the war and later wrote about their experiences consistently mentioned the EZ-8 as a turning point in their perception of American armor. Before early 1945, German tankers generally viewed Shermans as inferior targets that could be defeated through superior tactics and technology. After encountering EZ-8s, that confidence evaporated. Otto Carius, another highly decorated German tank ace who wrote extensively about his combat experiences, mentioned in his memoir that late-war American tanks demonstrated improvements that made them much more difficult to engage effectively. He specifically noted improved mobility and more aggressive tactics. While Carius primarily fought on the Eastern Front against Soviet armor, he encountered American forces briefly in early 1945 and recognized that American tanks had become more formidable. The psychological impact of the EZ-8 on German morale should not be underestimated. By early 1945, German tank crews were already demoralized by overwhelming Allied numerical superiority, constant air attacks, fuel shortages, and mechanical failures. Learning that American tanks had also improved in quality, that they were now faster and more maneuverable than before, reinforced the sense that Germany had lost the technological edge it had held earlier in the war. German propaganda had consistently claimed that German tanks were superior to Allied designs. Newsreels showed Panthers destroying Shermans. Training films emphasized German tactical and technical advantages. But propaganda could not change battlefield reality. When Panther crews encountered EZ-8s and found themselves unable to exploit the advantages they had been promised, the gap between propaganda and reality became impossible to ignore. This demoralization contributed to the rapid collapse of German resistance in the final weeks of the war. Tank crews who no longer believed in their equipment's superiority were less willing to fight to the death. They surrendered more readily. They abandoned damaged tanks rather than attempting repairs under fire. They avoided engagement when possible rather than seeking combat. The EZ-8 had not caused this collapse. German defeat was inevitable by early 1945, regardless of which tanks the Americans fielded. But the EZ-8 accelerated the process by eliminating one of the few areas where German forces still maintained a psychological edge, the belief that their tanks were better. In the decades since World War II ended, military historians have debated whether the EZ-8 arrived too late to matter strategically. Some argue that by the time it entered service in significant numbers, Germany was already defeated. The outcome of the war would have been the same whether the EZ-8 existed or not. American numerical superiority, air dominance, and logistical capabilities had already decided the result. Other historians argue that the EZ-8's impact, while limited by its late introduction, demonstrated important principles about armored warfare that influenced post-war development. The tank proved that mobility, reliability, and crew effectiveness were as important as firepower and armor protection. It showed that thoughtful engineering focused on practical battlefield requirements could produce better results than pursuing maximum performance in isolated categories. Both perspectives have merit. The EZ-8 did not change the outcome of World War II, but it did change how the victorious armies thought about tank design going forward. It validated design philosophies that prioritized operational effectiveness over theoretical superiority, and it provided combat experience that informed decades of subsequent tank development. For the German tank commanders who faced EZ-8s in the war's final months, the experience was professionally humbling. They had spent years developing tactics to exploit the Panther's advantages. They had trained extensively. They had accumulated hard-won combat experience. And then they encountered an opponent who could neutralize those advantages through superior mobility and aggressive tactics. Klaus Bärenfänger, the Panther commander from this story's opening, survived the war and returned to civilian life in West Germany. He worked as an engineer and rarely discussed his military service. In the 1968 interview with the German Military History Journal, he was asked about the most significant change he observed in Allied equipment during the war. His answer was direct. The improved Sherman, with wider tracks and better suspension, appeared in early 1945. It was faster, more maneuverable, and more reliable than previous models. It made engagements unpredictable because American tanks could move and react faster than we anticipated. Our tactical advantages in gun range and armor protection became less decisive because we could not control engagement ranges as effectively. The interviewer asked whether this meant the EZ-8 was superior to the Panther. Bärenfänger's response was more nuanced. He stated that in a direct frontal engagement at medium range, the Panther remained superior. Its gun could penetrate the EZ-8's armor more reliably than the reverse. But combat rarely consisted of ideal frontal engagements. Tanks maneuvered, they flanked, they ambushed, they pursued, and in those dynamic situations, the EZ-8's mobility made it a very dangerous opponent. That assessment captures the EZ-8's historical significance better than any technical specification. It was not necessarily the best tank in any single category. The Panther had a better gun. The Tiger had heavier armor. The T-34-85 had similar mobility with a lower profile. But the EZ-8 was the best balanced medium tank of late World War II. It combined adequate firepower, adequate protection, excellent mobility, and outstanding reliability in one package that crews could depend on. That balance made it more valuable in sustained operations than more specialized designs that excelled in some areas while failing in others. In the fluid, fast-moving combat of 1945, where armored units advanced hundreds of miles in weeks, reliability and mobility determined success more than maximum firepower or armor thickness. The EZ-8 was optimized for exactly that type of warfare. When the war in Europe ended on May 8, 1945, thousands of EZ-8s were in service with American armored divisions across Germany. Many would be shipped to the Pacific for the planned invasion of Japan, an invasion that never occurred due to Japan's surrender in August. Others would remain in Europe as part of occupation forces. Still more would be mothballed and placed in storage for future use. The tank's combat life had just begun. Its most significant battles still lay ahead in Korea. But in the context of World War II, the EZ-8 represented something important. Proof that American industrial capacity could produce not just quantity, but quality. That American engineering could innovate and improve, and that American armor could compete with and defeat the best tanks Germany could field. For years, German tanks had set the standard for armored warfare. The Panzer III and HVSS had dominated early campaigns. The Tiger had terrified Allied crews. The Panther had combined mobility, firepower, and protection in a design that should have been unbeatable. But should have been and was are different things. The Panther's theoretical superiority meant nothing when it broke down, when it couldn't maneuver effectively, when it faced opponents who could move faster and fight smarter. The EZ-8 proved that good enough, done reliably and available in quantity, beat perfect on paper, but unreliable in practice. That lesson applied far beyond tank design. It was a lesson about engineering philosophy, about military procurement, about the difference between impressive capabilities and effective combat power. Germany built tanks that should have won. America built tanks that did win. The difference mattered. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.